Yeah, this question. A particle of mass m moves along a horizontal x-axis from x equal to 0 to x equal to L. Okay. Now we will draw the graph here like this. This is your x-axis. Okay. This is coordinate 0. This is coordinate L. Now here there is a particle. You can consider a body of mass m. It is moving in this direction. Okay. Now in this case, coefficient of kinetic friction is given as a function of x. X means x coordinate. It is given how much? Mu naught minus alpha x. Got it? Now they are saying mu naught and alpha are that kind of constants, so that if I put here how much L, it will become what? 0. Got it? So first we will check this condition. What does it mean? It means if I am putting the value of x as what? L, then the entire answer will become 0. So we can solve mu naught minus alpha L equal to 0. So one condition we are getting, mu naught is equal to alpha L. We will use it. That's why it is given. We will check it. Now the point is that let's consider the block is kept here at how much separation at any instant at particular time t. It is here. It is having how much mass m. Okay, and it moves by how much? Dx only. Very small displacement. It moves. Got it? So in this case, how I can write the work done by kinetic friction? Work done by kinetic friction will be equal to mu k here, that is the coefficient of kinetic friction. How much it will be? Mu naught minus alpha x. Now try to understand, kinetic friction will act like this and the displacement dx is in this direction. So already I will take negative of this kinetic friction. It will be this mu naught minus alpha x into mg. This is the kinetic friction which will be acting in the backward direction. Negative I have taken because kinetic friction acts like this and the displacement is in this direction. Cos 180 already I have taken negative. Okay, multiplied by how much displacement in right direction? Dx. Got it? So this is a small work done. So I will write it d wkf, kinetic friction, work, small work done by kinetic friction. So this is from 0 to work done by kinetic friction. Now what we have to find? The total work done by the frictional force during the motion when it is reaching from this point to this point. It is given. So first we will find it. Let's do it quickly. Integrating it. So I will be getting minus, I will take outside, minus mg I will take outside. So this will become what? Now limit what I will be taking? 0 to L. So this part, if I am integrating, it will become mu naught. It will become what? Mu naught L minus this part, if I am integrating it, alpha x dx. So it will be alpha x square upon 2. So alpha by 2 L square. This is what I will be getting. Okay. Now solving it, minus mg mu naught L plus mg by 2 into L square into alpha. Now alpha is how much? It is mu naught by L. I am putting the value of alpha from here. Alpha will be how much? Mu naught by L. So I will solve it. So how much I am getting the answer? I will take, it will be minus 1 by 2 mg mu naught L. This is what I am getting. Okay. Now they are saying the total work done by the frictional force is N into mu naught into mgl. They are not taking negative. They are taking the magnitude here. So forget this negative. Okay. So we will be comparing this with how much? N into mu naught into mgl. So n will become how much? N will be equal to how much? 1 divided by 2, that is 1 by 2. What will be your answer? Option number 2. Okay students, this is how you understand it. Now try to understand. Calculus is there. Okay, so start learning calculus.